In this video we are going to study an HTML page called AtomCanvas.html. This is one more object-oriented application where we have one class and it contains animation, and then we are doing various things with the coordinate system so that we are stretching it and we are rotating it and we are going to translate it. We are going to study some mathematics of ellipses here, and we'll be using gradient colors in this application. So my name is Kari Laitinen, and let's go to see the page then. So you will find the page when you first go to naturalprogramming.com, and then after clicking this web icon you enter this page, and here you have a link Canvas-based pages, and there you will have this list, and the AtomCanvas.html is there, and you can download it with the right mouse button by clicking the link. I have the page here already running. I have downloaded it locally, and as its name indicates, it shows an atom. And the atom has a nucleus, and there are a couple of electrons rotating the nucleus there. And the page also, or the canvas, displays the number that how many frames are being displayed to the screen. So right now this page is showing that it is updated 90 times in each second. So the page looks like this, and well, I could actually hide it, and I have the page on paper here, or the picture of the page on paper here. So I think it is easier when we study it in paper form. I don't know how this will look in the final video, but this camera shows some strange coloring here, but they are not in the actual picture. But well, I have already the source code here in the editor, and let's start studying it. So basically, this source code is again very typical Canvas related page, so that there is quite a lot of JavaScript things first, and then there is a very short style definition section here, and again we specify that the canvas area is centered, and then the actual HTML part, or the body of the page, it's quite short, and we have the canvas element there, and the canvas element is inside the div that is centered, and the canvas has this ID AtomCanvas. And now we have this, when this page is loaded, this function run this application is called, and this run this application is a kind of game loop here. Here is the function, and this function just calls this draw on canvas, and then it sets this timeout of 10 milliseconds, and then it calls this same function again. So theoretically this could run something like almost like 100 times in each second. So, and then everything is then done in this JavaScript part of this page. So let's then see how this JavaScript looks like. So we have the draw on canvas method there, and we have one method or function named stroke oval, and then we have some public variables there, and at the beginning of this JavaScript section there is this one class called nucleus particle, and this nucleus particle represents these things that form the nucleus of the atom, so that there are altogether 4 of these nucleus particles, and well, they can be either protons or neutrons, and this class nucleus particle, it is a constructor, and we give in the constructor we give the particle the center point x and center point y, and then we give the particle color, and these are then made as data members or data fields of this class. And there is one method in this class called draw, and with this method the particle can be made to draw itself. And here we are using this thing called gradient color. So what is being done here, first, when this drawing context is received as a parameter, we first save it so that we don't disturb any other drawing operations, and then at the end of this method we restore the drawing context, and then inside with these statements we first translate the center point of the graphical coordinate system to the center point of the particle, and then we specify this thing called gradient color. So the gradient color means that the color changes gradually in some direction, so that but this is not, you can't see it well here. Let's take a look at the real thing. So the gradient color, it changes so that in this case it is almost white in the northwest direction, and then it is a very solid color in the southeast direction. And it seems that the light is coming from the northwest here. So this means the gradient color, and it is created with this special method of the context, so that there is this method create linear gradient, and then you add some color stops to the gradient color, and you can then specify with these parameters that from which direction this color changes. And in this graphical coordinate system there is this, well, the graphical coordinate system is like this, that the y-coordinate goes downwards and the x-coordinate goes to the right. So if we are using, so this is the negative area of the system and this is the positive area of the system. So we are first using here negative numbers here, and these are then positive numbers. So we specify then with these parameters we specify this direction like this, and that is the way how the colors change in the nucleus particle. And then we add 2 color stops to the color, and the first color is white, and then the last color is particle color. So the color will change then from white to this actual particle color. And after we have specified this gradient color here, then we just set that color as the filling color of the context, and then with these statements we draw the ball with that color. So this is how these nucleus particles are drawn. Well, then the actual main program begins, and here we specify these 4 nucleus particles. So there is upper left proton and lower right proton and lower left neutron and upper right neutron. The neutrons have a color purple, and then the protons have a color teal. And these parameters, they specify the center points of the nucleus particles. Well, then we have this electron angle, which is 0 at the beginning, and then we have a number of variables that count how many frames per second are being drawn to the screen. We can check these values later, or we will see later how these variables are used. And then there is this stroke oval method, because in this among these graphical drawing methods, there is no method for drawing an oval or an ellipse. So for that reason I have written this own method or own function for this, and you just give to this method the drawing context and the center point x and center point y, and then the width and height of the rectangle that can surround the oval. And here we use again these save and restore methods, and then we use this translate method, and we use this scale method so that we can make the drawing in correct way. But you don't have to really understand how this method or function works. You can just trust that it strokes an oval when it is called. Then there is this usual draw on canvas method, and this method is now called something like almost 100 times in each second. And here we first do the usual things. We get the reference to the canvas element, and we get the context, and then we draw the background of the canvas. So the background is this orange background, a nuclear color, and then we write this text here. So this variable tells that how many frames per second the system is now currently producing, and then again we save the drawing context. And here we are using some mathematics. So you remember that there is this electron angle variable that is a public variable here that tells that in which position the electron should be in a certain moment. And now we should be able to draw this electron on an elliptical orbit. So we are using this mathematical method methods, cosine and sin methods, to calculate the position, and the calculation is actually quite simple. So that I've made here a drawing, so that when we have some angle here, so we know this electron angle, and we should then get the coordinates of this point here. And now when we know the total width of the ellipse or oval, so we know that it is 400. This is 400, and this is now the height is 200. And so we know that this is then 100, and this is then 200. And so then we can use these values. So these values 200 and 100, they are being used here, and using this cosine and sin and the electron angle, we get the electron position x and electron position y. So we get the coordinates of this point in the elliptical orbit. So that is what is calculated there, and then we have to draw. You see that we have to draw this. We have to draw these orbits, and as well we have to draw the actual electrons there. So we first set the dim gray style, stroke style for the orbit, and then we translate the coordinate system to the middle of the canvas. So we will because as the normal 0 point of the canvas is there, upper left corner, but with the translate method we can translate it to the middle of the canvas, and then we do such things that we rotate the canvas 45 degrees clockwise, and then we call this function store oval, and we specify that the center point is 0, 0, and the width is 400, and the height is 200. And in practice, this call then produces this orbit here, because now the canvas is rotated. And then we change the fill style to red for the red electron, and with these statements we draw this electron there. Well, actually this draws so this specifies the electron, and this draws or fills the electron. So you see then, and then we are using the electron position x and electron position y that were calculated earlier. And then we have to draw this other electron orbit and electron. So we rotate now 90 degrees counterclockwise, and then we do the same things that we stroke the oval, we draw the orbit, and then we change the color to blue, and then we again specify the electron, and then here we draw the blue electron, or fill the blue electron. So that is how this is drawn. So the trick here is that we always rotate the coordinate system, and when the center point of the coordinate system is in the middle of the atom, these orbits, they look quite Nice. There. And you can see that if you turn it like this, you can see that both electrons are in relation to this oval. Both electrons, they are in the same position there. And then we again rotate this coordinate system 45 degrees clockwise, and then it's back in the normal position. And then we just call the draw method for each of these nucleus particle objects. So we draw these things here, and we restore the coordinate system. And then we prepare things for the next call for this function, so that we modify the electron angle. So we add math pi divided by 16 to the electron angle, and if the electron angle comes a full circle, then we set it to 0. And here we then calculate that how fast we are drawing the atom. So we record, because the current time it has been recorded earlier, and we take the previous time, we set the previous time as current time, and we get a new current time, and we use this date.now method. And this standard method, then it returns a number of milliseconds since the beginning of year 1970. And when we make this calculation, that we add the current time to the total time and subtract the previous time, we get this some value that if the total time is more than 1000 milliseconds, it means that it's more than 1 second since last operation. And so in that case we have to calculate the new value for the frames per second. So we subtract then 1000 for this total time, and because we have been previously calculating this value frames during last second, we set that as the new value for the frames per second, and we set this value to 0 again. So in practice this works so that you have to remember that this is now being called very often, this function, and we always increase the value of this variable, and once a second has passed, we set the value, we copy the value of this variable to this variable, and this variable is that is printed to the screen. And you can see when you run this program, so I reload the program now. So you see that this is, so it's 0 at the beginning, but it takes some time that it reaches the value 90. But the value of this value really depends on that which browser is in use. So I think I have explained the essential things about this application. So what we studied here, we studied an object-oriented application with animation. We studied how to scale and rotate the coordinate system and how to move its 0 point somewhere. And we studied some mathematics of ellipses and also the gradient colors. Well, thank you for watching and goodbye.